Rationalizing the denominator in Surd. The situation here is we're focusing on the denominator of a fraction. So there is, when the denominator is one term, and when the denominator is two terms. So we're going to solve for one term first. When we're rationalizing with one term, so what is one term? Example would be root a is one term. Two terms would be root a plus b, something like that. So that's two term, one term. So you have to watch out for this because when you see these things, it can be confusing. So let's try. We want to work on 9 over root 3. So the denominator is one term. The best way to rationalize it means, so rationalizing meaning that we need to get rid, we need to remove the surd in the denominator. So we don't want surd in the denominator. So removing, so this is removing surds from the denominator. So that's what we're doing. So that's what rationalizing the denominator implies. So what we can do here is we need to multiply. We know from surds that root of a times root of a will become a. So that's a good tool to use. We also know another tool to use is root of a. So b plus root of a. If I want to get rid of that surd, I need to multiply by its conjugate pair, which is b minus root of a. And that will give us b squared minus a. So that's how to get rid of that. That will give us b squared minus a. If we multiply it out, we get b squared minus a. And if we multiply root a by root a, I get a. So I've got 9, this is 9, not a. I've got 9 over root a, root 3, 9 over root 3. I will need to get rid of the surds. I need to eliminate the surds from the denominator, so I need to multiply both. So the 9 times root of 3 over 9, over root of 3 times root of 3. So I'm multiplying top and bottom by root 3, and that will be 9 root 3 over root 3 times root 3 is 3, and that becomes 3 divided by 9 divided by 3 is 3, so that'll be 3 root 3. So that's how to eliminate surds with one term denominator. With a two-term denominator, so if we have 7 plus root 5 over, let's say, 3 plus root 5, and I need to eliminate the denominator surd, that should become 7 plus root 5 over 3 plus root 5. I need to times both the numerator and denominator by the conjugate pair of the bottom denominator. So I have 3 minus root 5 over 3 minus root 5. So I'm timesing them together, and in doing so I could eliminate the bottom surd easily. The top is, I just need to expand them out. 7 times 3 is 21. 7 times minus root 5 is minus 7 root 5. 3 root 5 times 3 is plus 3 root 5. and root 5 times minus root 5 is minus 5. And I need to divide that by 3 times 3 is 9. 3 times minus root 5 is minus 3 root 5. Root 5 times 3 is plus 3 root 5, so that will cancel out. Root 5 times root 5, or root 5 times minus root 5 is minus 5, and that will give, well, 21 minus 5 is, well, 20 minus 5 is 15, and then 1, so 16, that's 16, and I've got minus 7 root 5 plus 3 root 5. It's like saying minus 7 oranges plus 3 oranges. I should have minus 4 root 5 over, now that will cancel each other. 9 minus 5 is 4 over 4. 4 is a common factor here. 4 common in the top. If I take 4 out, I get 4 times 4 is 16 minus root of 5, actually 1 root 5, but we don't write 1 because it's default, so you don't write default in maths. And then you divide that by 4, 4 cancel 4, the final answer will be 4 minus root of 5.